Hello guys, welcome back to VC Tech. In the previous video, we talked about how to configure VoIP for IP phones and establish basic voice communication within the network. However, in today's video, we are going to be taking that a step further by configuring both voice VLAN and data VLAN for an IP phone and PCs connected within the same network environment. We will look at how traffic separation works, why voice VLANs are important in enterprise network, and how switches intelligently handles voice and data traffic differently to improve performance, security, and quality of service. By the end of this video, you will understand how to configure a switch port for both voice and data communication, verify connectivity, and also ensure proper VLAN segmentation for real-world VoIP deployments. So, if you're interested in networking, Cisco configuration, or enterprise VoIP setup, make sure to watch this till the end. For this tutorial, we are going to be making use of a 2811 router and also a 7960 IP phone. Always remember that voice VLANs are mainly used to separate voice traffic from normal data traffic. This helps improve call quality and reduce unnecessary broadcasts on the network. In case you're wondering why I've not connected the PCs to the switch, it is because the IP phone is going to be acting as a small switch. The PCs will connect through the IP phones, while the switch will intelligently separate voice and data traffic into different VLANs. If that's confusing, there is no problem. Before the end of this video, you're fully going to understand what I'm talking about. We are going to be creating VLAN for voice traffic and also data traffic. Now let's comment our configuration from the switch, then we move over to the router. Now on the switch, we are going to be creating VLANs, two VLANs for the data and also for the voice. So VLAN 10, this will be taking the voice VLAN, so this will be voice, and VLAN 20, this will be data VLAN. Since we have two VLANs on the network, we are going to need to configure this interface that is directly connected to the router to serve as a trunk port. So interface FA0/1, switch port mode to be trunk. Now let's assign ports. Let's assign this port to their respective VLANs. So interface range FA0/2 to 4, switch port mode to be access, switch port voice VLAN 10, and also switch port access VLAN 20. Earlier we talked about how we are going to configure a switch port for both voice and data communication. So this is what we just did right now. We configured switch port FA0/2 to FA0/4 to serve as both voice and data VLAN. Now let's try to troubleshoot to see what we just did on the switch. So we can do that by saying do show VLAN brief. You can see we have our voice VLAN 10 as well as we have our data VLAN 20. Now our voice VLAN 10 and our data VLAN 20, they have FA0/2, 3, and 4 in common. Let's also head over to our router where we get to configure sub interfaces, DHCP, telephony service, and also die number. So we say no, enable, configure terminal, configure terminal. On the router, first we want to enable the interface FA0/0. We want to say no shots to bring that interface up. Now after doing this, it's time for us to create sub interfaces for the voice and also the data traffic. So interface FA0/0.10. Before we assign IP address to this interface, we are going to need to encapsulate that interface before we can assign IP address to it. However, let's try to assign IP address without encapsulating and we see what it's going to happen. Remember, if we hover above the the router, you're going to see that we don't have any IP address, but we have the sub interface for VLAN 10. Now let's assign IP address to that interface, 192.168.10.1 with a subnet mask of 255.255.0. Now you can see that it is not allowing us to assign IP address to that interface, as if we should hover above the router once again, you're going to see that it does not assign IP address to that interface. Even though we've created a command to assign IP address to that interface, it still did not work. Why is it not working? It is not working because we've not encapsulated that interface to serve as a sub interface for VLAN 10. So we can do that by saying encapsulation.1q, and we specify the VLAN number, which is VLAN 10. Now let's try to assign the same IP address that we did previously and did not work. So now you can see we are able to assign IP address to that interface after we encapsulated that interface. So if we should hover above the router one more time, you're going to see that we have an IP address for that interface, which is a sub interface VLAN 10. Let's also go and create another sub interface for VLAN 20, which is interface FA0/0.20. Then we also encapsulate the ports to enable us assign IP address to it, .1q, and we specify the VLAN number, which is 20. After doing this, let's assign IP address to that interface, 192.168.20.1 with a subnet mask of 255.255.0. Now we've assigned IP addresses to the sub interfaces of VLAN 10 and also VLAN 20. Let's take our configuration one step further. Now we are going to be creating a DHCP server to assign IP address to both voice and data VLAN. So first we need to let the router know that it is going to be serving as a DHCP server for the host devices. Then we create our DHCP pool. IP DHCP pool, we want to call this voice. Now let's specify the network of the voice VLAN. So 192.168.10.0 with a subnet mask of 255.255.255.0 and a default gateway of 192.168.10.1. And next on our configuration is going to be the option 150 with an IP address of 192.168.10.1. Remember, the IP address is always the default gateway IP address of the voice VLAN. So what does this line here simply mean? Option 150 in DHCP is used in VoIP network to provide IP phones with the TFTP server addresses, where they download their configuration and also firmware to register and operate. Now let's also go and create a DHCP pool for the data traffic. So we say IP DHCP pool, and this is going to be called data. Let's also specify the network, which is 192.168.20.0 with a subnet mask of 255.255.0 and a default gateway of 192.168.20.1. So this is all we are going to be needing to configure DHCP pool for the data traffic. Now let's go and configure a telephony service to let the router know how many telephones we have on the network and how many die number that we are also going to be needing for the network. So we can do that by saying telephony service. Then we specify the maximum ePhones that we have on the network. The maximum ePhones are 3, and also the maximum die number is also going to be 3, since we have just 3 devices, 3 IP phones on the network. Next, we want to specify the IP source address. The IP source address is the default gateway of the voice VLAN. So 192.168.10.1 and port 2000. Next, we also want to specify the auto assign 1 to 3. Auto assign 1 to 3. This is how they'll be getting their die number. The auto assign is there to help them get their die number without us interfering. We've already done the configuration. Now we are done with the telephony service. Now let's finish up our configuration by configuring the die number for each IP phone we have on the network. So we can do that by saying ephone die number 1, and we specify the die number for this to be 1011, and die number 2, ephone die number 2, we want this one to be 1022, and the last ephone die number, we want this to have the die number of 1033. By doing this, guys, we've configured on the router sub interfaces for VLAN 10 and also VLAN 20, as well as we created a DHCP pool to assign IP addresses to the host devices on the network for both voice and data traffic. After doing that, we created a telephony service letting the router know that we have 3 ePhones on the network and we are going to be needing 3 die numbers. We also specified the IP source address, which is the default gateway of the voice VLAN. And lastly, we specified the ePhone die number, and we also give them a number that each phone could use to communicate with another device or another IP phone on the network. As soon as you know all that, let's connect our PC to our small switch or the IP phone. So remember, the IP phone is going to be serving as a small switch to the PCs, while the switch will intelligently assign data where they are supposed to go to. If the data is supposed to go to the PC, the switch will handle that, sending it to the PC, and any data that is supposed to go to the IP phone, the switch will also assign or send that data to the IP phones. Since we've connected our devices, let's also power on our IP phones and wait for them to get their IP address and also their die number from the configuration that we just did. As you can see, our ePhones are now being registered to their respective devices. We have 1, we have 2, and we also have 3. Now let's go and hover above the IP phones and see if our devices has gotten the IP address. Yes, they've gotten IP address as well as they've gotten their die number. As if you should look below, you're going to see something called a line number. A line number is also a die number. And on this device, it has gotten its IP address and also a line number. And on the last device, yes, it has gotten IP address and also a line number. Now let's go and test our configuration. First, let's start with the IP phones. Let's try to use this IP phone to call another IP phone on the network. So we drag and keep this here. Then we bring out another IP phone, another IP phone, and we drag and keep this here. So this IP phone has a die number of 1022 and this IP phone has a die number of 1011. So let's use this IP phone to try to call the 1022 IP phone to test our configuration. As you can see, our configuration is accurate as 1011 IP phone can communicate with 1022 IP phone. As you can see, it is showing us connected and it is connected to 1022, and this one is also connected to 1011 device. Now let's head over to our PCs, and if we should hover above it, you're going to see that it has not gotten an IP address yet because we've not assigned or we've not told the PC where to get the IP address from. So you click on the DHCP server and you're going to see the DHCP server request was successful. This device has an IP address of 20.2. Let's also do the same for the other PCs on the network. So click on this to get an IP address. It was successful, and let's do the same for the last device. And for this device, we are also able to get our IP address. Now let's try to ping from this device to another device on the network. So let's ping, first of all, let's ping the voice VLAN. So let's ping 192.168.10.2. As you can see, we are able to ping the IP phone on the network. Let's also ping the PCs on the network to see if it's going to work. So 192.168.20.2. 20.3. So we are also able to ping both the voice traffic and the data traffic on the network. Understanding voice VLAN and data VLAN configuration is very important skill for network engineer, because this is something commonly implemented in real enterprise environments. So if this video helped you understand how to configure voice VLAN and data VLAN on the same ports, why not smash the like button and subscribe to this channel, because I hope to see you in the next video where we'll be talking about something even more interesting. Thank you for watching this video, and I hope to see you in the next.